osmotic pressure on the inside or on the outside of the cell there. So if you have a hyperosmotic solution there, and that results in the swelling of the red blood cell, that is dangerous. And then if you have hyperosmotic solution, that will result in the water inside the cell coming out. In both situations, we should try to avoid both situations here in medicine there. And what we want to have is the isoosmotic solution. A solution with the same osmotic pressure, so that water will not flow in or out of the cell in an attempt to increase the volume or decrease the volume of the cell, or rupture the cell, or shrink the cell, or kill the cell. So osmosis has a lot of application in everyday life. And on a particulate level there, what happens here is that we know when we have ions, inorganic compounds dissolved in water there, those ions were actually hydrated. As a result, the size of the ions are actually bigger than just in water solution, than just the ion. So because of the attraction of the cations and anions for the water molecules there, we talk about water being a polar solvent. There's a positive end of water molecule, negative end of water molecule. Now, as the result of hydration, the ions becomes larger. As a result, they cannot pass through the little openings on the semi-permeable membrane. Only a water molecule can go in and out. Okay, so this is the application of on the particulate level there, and we can see why only solvent molecules are allowed to move in and out of the a particular container there, separated by the semi-permeable membrane. And the pressure generated by that osmosis process can be used to purify water. Now, you've heard this probably on a regular basis there, reverse osmosis. Now, regular osmosis process there is that when you have seawater with a high salt content and you separate them with the semi-permeable membrane with fresh water, well, under the normal condition, the fresh water will make an attempt to get into the seawater side. However, if you apply enough pressure on the side with the seawater, you will be able to push the water, pure water molecule, through the semi-permeable membrane. And this is a water purification process. And some of the enter the counter, enter the sink, reverse osmosis. When you have your water inline connected to that device, and then there's a water outgoing, and there's another tubing connected to your faucet. When you turn on the water there, water from the city source or well comes in, and the pressure is being applied, and the pure water is being pushed onto the other side, and where you have your faucet connected to it. Now, the problem there is that this particular process actually removes everything from water. And what you got on the other side is just pure water. And you may think, well, isn't that a good thing? Well, it depends on what you need. If you just need water, well, that's a good thing. But the thing here is that for drinking water, the spring water actually have minerals dissolved in them. Those minerals are essential to human health. So if you use reverse osmosis, you're removing not only the things you don't want, also the things that you do want. The beneficial minerals dissolved in there will also be removed. So it depends on what you're trying to, how you look at the situation there. And reverse osmosis can be used to get pure water, but the result of getting pure water may not be exactly what you want in terms of your healthy diet and a good water to drink there. And also, if you try to do this on a large scale, like what you see in the picture here, removing the salt from seawater. This is a project that, in theory, it's a great idea, but the thing here is that it just costs tremendous amount of energy. It's very expensive, and so some of the countries with along the coastlines of the Pacific and Atlantic Oceans there, and you have an unlimited supply of water there, but you can't really use them unless you remove the salt dissolved in there. And using reverse osmosis is one of the applications, one of the things we can do, but it's very costly as well, because you have to maintain that constant pressure, and you have to replace the semi-permeable membrane every once in a while. At least you need to backflush it. Okay, so that's the application there. Now, these are the colligated properties of solution there. Okay, when you have something dissolved in the solution, well, it's gonna and then when you have that solution put next to a pure solvent there, and osmosis happens there. Okay, and when you have a solution versus a pure solvent, and the freezing point is depressed, boiling point is elevated, and the vapor pressure is lowered. So those are the things that, and some of the quantities there we can use a mathematical equation to do calculations. Some of the things we just need you to remember or memorize. Okay, so that pretty much wraps up the topic in chapter 12 there. And make sure when you read chapter 12, there are many other topics covered in the textbook there. But try to focus on the topics discussed in class there, and make sure you, if possible, make sure that you work on the problem assigned in chapter 12 there. Okay, and it's 8:50, and I told your lab instructor that we are going to start our lab at 10 o'clock today. So I have roughly about an hour and 10 minutes. So we will take a short break, and after the break, we will take a look at chapter 15 and talking about the acid base. That will conclude our lecture for this class, this semester there. So let's take a break, and then we'll come back and we'll start chapter 15. Now again, whatever is due today, and if you have it ready, you can put it in the folder, and if you don't, I will give you till Monday. Monday is the absolute deadline. I have to have everything. And those of you who are taking the exam in the test center, the last day to take the exam is Monday. Okay, you cannot go beyond Monday, and I need the result back at least by Tuesday, and so I can report the grade. Right, so we will have our final exam in class in this room next Monday at 8 o'clock. We'll have 2 hours. Everything in the folder is yours to keep. I just need you to put in whatever you need to turn in. Put whatever you need to turn in the folder.
Yeah. My leg is asleep. You need your left, right? Yeah.
Well, hydrogen.